Okay, so for the Arrhenius equation, as the temperature increases, the rate constant is likely to increase as well. This is due to the fact that there will be an increase in the kinetic energy of the particles, and the average kinetic energy of the particles within the reaction, increasing the strength and velocity of the collisions, leading to higher or stronger and more frequent collisions, and thus a faster reaction and rate of reaction. The Arrhenius equation shows the variation of the rate constant with temperature. It is given by the formula K, or rate constant, equals A E, which is a natural log function, to the power of negative activation energy divided by R, which is equivalent to the gas constant, and times T, which is equivalent to temperature. A is called the pre-exponential factor, the A factor, or the frequency factor, and contains information that relates to the frequency of collisions, as well as the orientation of collisions. A is essentially a constant, and it only varies only slightly with temperature. So due to natural logarithms, we can rearrange this formula to be written as ln k equals negative EA divided by R times 1 over T, which is the same as over RT, plus ln A. This, by using this formula, we'll be able to determine a value for the activation energy in the reaction. However, to do this, the following procedure is recommended and required. Firstly, you'll need to conduct a series of experiments at various temperatures, and you have to calculate the rate constant for each temperature. Then you would need to calculate, plot it on a graph and determine the gradient, which would hence give you the activation energy. The activation energy, the graph would look like this. The y-axis would be ln k, and this is extremely important. The x-axis would be 1 over t. Let me make that a bit more clear. 1 over t, and this would be measured in the reciprocal of the Kelvin. So since it is a reciprocal value, we would be expecting to see a negative gradient, something along these lines, and the value of this negative gradient times negative 1, since we have 1 over the negative times activation energy. The value of this gradient times negative 1 would be equivalent to the activation energy measured in kilojoule. Then another thing we need to consider with regards to the Arrhenius equation is the presence of a catalyst. So the catalyst is used in a reaction to speed up the reaction without actually being consumed. So there's no increase in temperature, but there's an increase in the frequency of collisions. And thus, knowing that the frequency of collisions increase, it is to increase the value of the rate constant. So K is likely to go up due to the presence of a catalyst.